Hello, Algebra 1, and welcome back to Topic 6, Solving Quadratics in Vertex Form. This is actually our second to last lesson in this little mini unit here. Next class, we're going to try and connect everything we've done so far. But for this class, we need to actually focus on solving quadratics. Now, as a friendly reminder, quadratic equations are any equation that have a square in them, right? Those little exponent of a 2. And so we can see all these problems down below that we're going to look at will have a square in them. As a heads up, if you have not done lesson 6.3, the one from last class, on using and simplifying square roots, you absolutely need to do that one before this one, because a lot of what we do here today is going to be based off of that lesson. So make sure you're ready there. You will also want a calculator for today, so make sure you are ready for that. With that being said, let's go ahead and rock and roll. Before we learn how to solve any equation, we've done this all year long, we first need to make sure we understand how to check our solutions, because checking a solution is the same process every single time. To check a solution, we take an answer, whether it's given to us or we're just guessing at one, and we substitute that value into our equation. Right? So for example, on part A over here, we see x equals -2, and notice that in math a lot of times we'll put answers in these braces, and you use those a bunch when there's more than one answer too. It shows us that there's a list of answers instead of a point or something else, and we take that value, in this case -2, and we replace every x in the original equation with that value. In this case, there are two different x's we're going to have to replace with -2, and they're both on the left side of the equal sign. So I'm going to go ahead and draw kind of a little barrier here to show we're not doing things to both sides. We're just following PEMDAS here. And so the right side is going to stay -8 every time. I'm not actually sure there's going to be 4 lines, but I just wanted to fill up the space and show you that that will be -8 every time. So what do we do from this point? Well, we replace the x's with -2. And now we're just going to simplify one side of this equation. And there's always 2 rules that we need to follow whether we are simplifying or solving. And so when we're simplifying here, we always simplify by following the pattern of PEMDAS. Right? PEMDAS goes with simplification. Now later on, when we solve equations, solving equations is when we work backwards, when we do SADMAP. But for now, we're going to start top to bottom and do PEMDAS, and I'll cross them off as we get to them. We first look for the parentheses on this left side, but inside the parentheses there's just single numbers. We can't simplify the inside of the parentheses, so we're out. Next we do our exponent. There is an exponent here, and we need to remember that a square means we take -2 and multiply it by itself. -2 times -2 is a +4. So now we've taken care of the exponent. Next, we do any multiplication and division we see in the problem. I do see a 6 times -2, which is -12. Notice you could write this as ±12, but most of us in our experience would say +6 times -2, cool, that's -12. And then we simplify from here. 4 minus 12, that is -8. We're doing the subtraction portion of PEMDAS, and we see that -8 equals -8. That's important because it tells us -2 was a solution. All right, let's go ahead and try the rest. So there are 3 more of these for you to try. They can be a little tricky with that square root, and we'll touch base on that in just a second. And then once you've tried one of them, you can come back and make sure you did the answer correctly. Ready, set, go. All right, and we're back. Now, you might have gotten a little stuck on part B, especially because they asked you to not use your calculator here. So I think this is definitely worth talking about. Same first step. We are going to replace the x with the answer, and I'm going to go ahead and put a couple of these here. The x is getting replaced, need a little bit more room, with the square root of 3. Now you guys hopefully will remember last class that most square roots give us irrational answers. They give us, we called them gross decimals. And so if you wanted to look at what that looks like here, I could do the square root of 3. I'm using my Desmos scientific calculator, and you can see the answer is 1.732, but it goes on forever and ever and ever. We don't want to write that when we substitute this in. We want to keep it as the square root of 3. We want to keep the problem looking as nice as possible. Well, what do we do here? Well, there's two ways to do this. The first way, even though it said not to use your calculators, you could try your calculator and do the square root of 3 squared. Right, I'm over here, I have this square root of 3, and I can hit the squared button, and the square root of 3 squared tells us, whoa, that's weird, it's just 3. That's strange. We took this really weird gross number, and when we squared it, we just got 3. Is there another way we could think about that, though? Why is the square root of 3 squared equal to 3? And so I'm going to write that just so we can keep track of what we're doing, but then on the other side over here, we're going to go through the process. Well, the square root of 3 squared can really be thought of as the square root of 3 squared. We can do the square before the square root. We can actually do them either order here, which is interesting. Well, think about this process. 3 squared gives us 9. We multiply a number times itself. But then the square root of 9 says, what number times itself is 9? And you're like, wait, are we going in circles? And yes, you kind of are. The number square rooted of 9, or the answer to the square root of 9, is the number times itself that equals 9, which is 3. So really, a square and a square root are inverse operations. They do the opposite of each other, right? One of them multiplies it times itself, that's the square, and the square root finds the number that multiplied times itself. So that's actually really exciting, because whenever you see a square root and a square, we say that they undo each other and just leaves us with the radicand, or the number inside, and that's awesome. Once we're here, we just simplify. 3 minus 3, that's 0, and I didn't even need this last line. 0 is the same as 0, so we're good. All right, now that you know that, go ahead and try these last two, and again, unpause whenever you're ready. All right, this one is a little bit trickier for sure. Let's see how we can do this. We're going to replace the x with a little bit more complicated of an expression, 2 square roots of 2 here. And I'm going to be pretty tricky here. I'm going to take 2 square roots of 2, and I'm going to write it times itself. 2 square roots of 2 times 2 square roots of 2 minus 8, and we're going to see if that equals 0. Doesn't seem like it so far, but we may have to simplify a little bit more. We're going to get more creative. The 2 is attached to the square root of 2 by multiplication, and we should remember that whenever you have many numbers multiplying, you just switch around the order. So when you switch around, or you are allowed to switch around the order. So what that means is I can write this 2 and this 2. I can write these 2's right next to each other. And then I can write the square root of 2's right next to each other. Well, 2 times 2, that's easy. That's just 4, isn't it? What's the square root of 2 times the square root of 2? Well, kind of giving you a visual over on the other side. Square root of 2 times itself. Isn't that just a fancy way to say the square root of 2 squared? Something times itself. And we just learned that square roots and squares undo each other. And that gives us 2. So the square root of 2 times itself is just 2. Minus 8 is supposed to equal 0. I'm going to use the space down below. Let's do a little bit of math at the same time. 4 times 2 is 8. And isn't 8 minus 8 equal to 0? So the left side does equal the right here. Okay, last problem. It did say you could use your calculator on this problem. You actually don't have to, and I'm not going to, but if you wanted to use it, that's totally okay. So here's how this one works. We're going to take x, and it's going to be replaced with this crazy thing right here. So we have 1 minus 2 square roots of 3, and then there's a minus 1 and a square and a minus 12, and all of that is supposed to be equal to 0. Can you see how I just rewrote this down below but replaced x with what they told us x was equal to? Now simplifying, you'll notice that there's nothing outside of these parentheses, so I actually don't need those parentheses there. I always start with the parentheses, but then we can drop them once we realize that nothing is attached to them. Now, let's follow PEMDAS, right? The P says simplify the parentheses. Okay, to simplify the parentheses, 1 is going to cancel out -1. 1 minus 1 is 0. And so I think all this leaves me with then is -2 square roots of 3 with a square minus 12 equals 0. I can already tell I'm going to run out of room here. I'm probably going to have to do some arrows in a bit, but that's okay, I think. -2 square roots of 3 squared, well, we've seen this before. We're going to use our same trick and write this times itself. That's what a squared means. And then we're going to rearrange -2 times -2 times the square root of 3 times another square root of 3, which really means the square root of 3 squared. Okay. And then we continue over. -2 times -2 is +4. The square root of 3 squared, ooh, those ones undo each other. They cancel, right, to just give us 3. Okay. 4 times 3 is 12. And 12 minus 12 is 0. 0 does equal 0. Okay. So I think this opener here does a bunch of things for you. First, it shows you that square roots undo squares. Second, it reminds you of how to check solutions. We substitute those values in. And third, it reminds you of how to deal with some of these squares. Something times itself gives you a couple cool little shortcuts here, right? Now, we haven't actually solved anything yet. All we did here is we used PEMDAS. We simplified each side. And this would be really, really tricky, I think, if, let's say on part C, I didn't tell you the answer. And I said, guess what the answer is? Who would guess 2 square roots of 2? And so what we're going to focus on today is how did we find an answer of 2 square roots of 2? Now, before we get to that, this is the second out of 3 parts for today, there are some properties that we need to know about squares and square roots. And a couple of these we already know. So, the first one is that what do square roots do with squares? So, for example, if I'm looking at 1a here, the square root of 4 is really the square root of 2 squared. And we saw earlier that square roots and squares are inverses of each other. They undo each other, and they just leave us with the inside. And so we say square roots undo or cancel out a square. And that works without numbers, too. The square root of x squared, that's just x. The square root of x minus 3 squared, that's x minus 3. Very easy, right? Nothing to it. But 2 is something different. And actually, before you do that, you might want to star 1. That's one of the most important things that we're going to need for today, that we can use square roots to undo squares. But let's get to 2, because 2 I think is pretty fascinating. 2 says the square root of a negative number. So looking at, let's say, 2a over here, I'd like you to take your calculator out and type in the square root of -4. And I'm going to do the same thing on my Desmos Scientific calculator. So I'm going to clear this out, and we're going to do the square root of -4. Whoa, this one says that's undefined. Undefined, what does that mean? Why would it be undefined? Now, your calculator may have done some other things. They may have given you error, or they may have done what mine did and said undefined. In fact, in math, a lot of times we'll call this DNE, which means does not exist. Okay. Either way, though, it is not an actual answer. Why? Well, some of you might have said, well, isn't the square root of -4 equal to -2? But if you check that, -2 times itself equals +4. And square roots only give us, or have to give us, an answer that when you multiply the exact number times itself, gives you the answer inside the square root. And 4 is definitely not the same as -4. You could say, well, yeah, it is. There's just an extra minus in there. That minus changes the number. They are not the same. And so, I think you'd be very hard-pressed to find a number times itself that equals a negative. right? A positive times itself, positive times a positive, is a positive. A negative times itself, a negative times a negative, is a positive. In fact, you might be tempted to say, oh, there are no numbers times itself that equal negatives. That's silly. And at this point in time, you'd be right, because you don't know those numbers. But what's actually going to happen is in the next year or two, you're going to learn that there are extra numbers that you haven't learned yet called imaginary numbers, that when you do multiply them times themselves, they do equal negatives. But that's a conversation for a different class. Either way, though, probably the best way to say this is that the square root of a negative number is not a real number. So you're going to learn about those non-real numbers, those imaginary numbers, in Algebra 2. 2b, DNE is usually what I'd put here, not a real number. 2c, though, is interesting. 2c asks us about cube roots, and we learned that last class as well. The cube root is looking for a number that when you multiply it by itself 3 times, you get negative 8. And what you're actually going to find here is that that answer is negative 2. Because, well, if you do negative 2 times itself 3 times, negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. So this starts to get pretty interesting. Square roots have an invisible 2, that index of 2 there. Square roots do not have real answers when you do the square root of negatives. But cube roots do, because an odd number of negatives can multiply to equal a negative. An even number of negatives cannot. Now we're again just going to focus on square roots, but I think it's important that you guys don't come up with the idea that only that all roots, all radicals of negatives don't exist, because some of them do. In fact, half of them do. But again, a conversation for another day. All right, let's get to it. These ones go much faster. The next thing we're going to look at is, when are we allowed to use shortcuts? Because, and this is very, very, very important to realize, PEMDAS is the boss in math. PEMDAS is always right. If you ever get stuck on a problem, you're like, oh, I don't remember these extra shortcuts my teacher showed me, go back to PEMDAS, because PEMDAS will always get you the right answer. But sometimes PEMDAS is slow. Sometimes you want to use a shortcut, and sometimes you want to skip around with PEMDAS, and sometimes you can. But of course, sometimes you can't. So what we're going to look at here is the biggest shortcut we learn in Algebra 1, distributive property. And we're going to see when are we allowed to distribute and when are we not. And we're going to start with squares. So we're going to look here at 3a and think, well, am I allowed to distribute this square inside? And the way we're going to do that is we're not going to distribute the square so that we find the right answer first. And the way that we know we found the right answer is we are going to follow PEMDAS, because PEMDAS always gives us the right answer. So to do PEMDAS first, to figure out what that right answer is, okay, we just do what it tells us to do. It says do what's in the parentheses first, so do 2 times 3, that's 6. Cool. Then PEMDAS says now apply the exponent. 6 squared, that's 36. And then PEMDAS says do the rest, but there isn't anything else. We found that 2 times 3, that quantity squared, is 36. That is the right answer. We did PEMDAS, it has to be right. However, let's see if our shortcut works. Our shortcut works by seeing if we can distribute. Not PEMDAS, this is a shortcut. I'm going to actually write distribute over here just to see how things are looking. Okay, and it becomes 2 squared times 3 squared. I distributed the exponent. Now we can simplify. 4 times 9, and 4 times 9 is 36. We are allowed to distribute an exponent when there's multiplication inside of parentheses, and that's awesome. In fact, it shouldn't surprise you too much that if you're allowed to distribute to multiplication, you can also distribute a square to division. Multiplication and division are linked with each other. Generally, whatever works with one will work with the other. So when you're asked to do 3/4 squared, the quick way to do this is to just do 3 squared divided by 4 squared. Distribute your exponent, 9/16. Could you use PEMDAS? Certainly. 3/4 squared means 3/4 times itself. That's using the exponent. And then we use multiplication and multiply straight across, and that works too. Last but not least, I see multiplication. We are allowed to distribute an exponent here. That becomes 5 squared times x squared, which is 25x squared. You should note, though, that this answer, and I see this come up a bunch with students, is different than 5x squared. Sometimes I see students say 5x squared, oh, that's 25x squared. No, it's not. If it's 5x in parentheses squared, then yes, that is 25x squared. But if it's just 5x squared like this, the square is only attached to the x. This 5 actually has an invisible 1 if you want, because it's 5 times x squared. But we need to make sure that we don't say 5x squared like, oh, we distribute the square, only if there's parentheses. Now, let's go ahead and play that same game again, but now with addition and subtraction. So if I'm adding here, let's try PEMDAS to get the right answer first. Okay, our right answer, again writing PEMDAS over on the side, says do what's in the parentheses first. So 3 plus 4, that's 7. And then square 7, 49. The right answer is 49. PEMDAS never lies. Let's see if we can do our shortcut. Let's try to distribute here, just like we did before. Distribute the 2. So we end up with 3 squared plus 4 squared, looking good so far. 3 squared is 9, 4 squared is 16. Okay, and then 9 plus 16, I think that's 25, isn't it? Uh-oh, we have a discrepancy. We have a difference between the two. 49 versus 25. Which one's correct? PEMDAS. PEMDAS is always right. So what this shows us is that we are not allowed to distribute a square if there is addition, and because addition and subtraction are linked, you also cannot distribute a square with subtraction. In fact, over here it tells you if you do that, it not only gets you the wrong answer in math, which is bad, it also kills puppies, which sounds extreme, but this is one of the largest issues we see in second semester of Algebra 1. We see people distributing everywhere, and they forget that distribution is a shortcut and it doesn't always work, and this is a case where it doesn't work. So you might see this written on your papers if in class you try to distribute this and you're like, ooh, x squared plus 6 squared, that's x squared plus 36. You might see something like this and it might say kills puppies, and then there's going to be a sad face next to it, because we don't want to do that. I love dogs. I have a dog. I love puppies. We want to keep the population of puppies up. Don't distribute a square. One more time, just a friendly reminder. Don't distribute a square, and I guess I should go further and say if there is addition or subtraction. Multiplication, division, go for it. Addition, subtraction, no. That kills puppies. Sad face. Now, some students ask, well, wait, if we can't distribute a square, how do we do this? Well, if there is only numbers inside, you follow PEMDAS and it gets you the right answer. If in this case there are not only numbers inside, there's variables, then you're going to learn some different ways to evaluate this or to expand this or to simplify this, but that's going to be further down the road. Okay, now let's go ahead and expand this out to square roots. Right? We just learned all these rules for squares, when we can distribute, when we can't. Do we have to learn them all for square roots too? What if they're different? Well, just like multiplication and division go together, and just like addition and subtraction go together, they all have their own same linked rules. Squares and square roots do as well. So any of the rules that were true for squares are also true for square roots. Multiplication? Yeah, distribute. There's nothing wrong with that. Right? We get 2 times 3, which is 6. All right. Addition, well, don't even think about it, because just like with distributing a square, you cannot distribute a square root with addition. That kills puppies. Sad day. But what about 5C? Oh, this is just division. You can distribute a square with division, so you can distribute a square root with division. And so we get 2/3. Squares and square roots have the same rules. Distribution is a good shortcut, but only with multiplication and division. All right, we've actually learned enough now to start solving equations. There is one more small piece, but it's nothing too terrible. And so we're going to go ahead and start solving. Now, everything we've done so far has been simplifying. Everything we did so far used PEMDAS. Once we start solving, SADMEP, working backwards, I'm going to write it over here for you, is king. We are now undoing things that are happening to x. When you do things to x, you follow PEMDAS. When you undo, when you get x by itself, you use SADMEP. So to do that, we need to remember we start with addition and subtraction and undo that. Then multiplication and division. Then at the very end, we undo exponents. Right? In fact, last semester, we only used these first two steps. This semester, we're expanding to exponents. So let's get to it. 6a, x squared equals 9. We need to ask our question, why is x not alone? Or maybe a different way to think about it, what is attached to x? Well, there's this number attached to x. What kind of number is that? Well, that's a 2. But when I say kind of number, what I really mean is, how is it attached? And the 2 is attached because it's an exponent. So we need to undo that exponent. Again, we always think SADMEP. I'm going to write this pretty much every time until it's drilled into your brain. We think, is there any addition or subtraction attaching the 2 to x? No. Multiplication and division? No. It is an exponent. So the only thing I need to undo is the square. But how do we undo squares? We learned that on step 1 up above. We said, and I even started, square roots undo squares. So when I'm down here, I'm going to undo the square with a square root. And this shouldn't be too bad. You're going to say, oh, x equals, well, the square root of 9. What is the square root of 9? Well, I'm going to say the square root of 9 is -3. Now, you guys might have said, wait. The square root of 9 is 3, because 3 times 3 is 9. And you're right, the square root of 9 is 3. But am I wrong? If I check this really quickly, -3 times -3, a negative times a negative, isn't that a positive? So I think I'm right too. So who's more right or the most right? Well, it turns out I think we're both correct here. And so you actually do need to write both answers to a square root. One positive, one negative. Now there are a couple ways you can write these answers. I'll give you like 3 options over here. One way is you can write them both separately. That's probably arguably the slowest way. The slightly faster way is you can use those curly braces over here, and we can do -3, 3. And so that's just listing out the answers. There's 2 answers. But maybe the fastest way and the most common way is if you get 2 of the same answer, you list it like this. You say x equals plus minus 3. A lot of times you'll see that in the curly braces as well. And what that's saying is that there are 2 numbers here. One is a +3, one's a -3. And in fact, in math, if you ever introduce or write in a square root like I did in yellow up here, you are required to put a plus minus out front. You are required to show that there will be 2 answers. That is the only other trick, and in fact at this point you should be able to solve every equation in the rest of this packet. However, what we're going to do is I'm going to have you guys, after each problem I go through, I would like you to pause and then you need to try the problem. If you keep the video running and just have me do it for you, your brain will never switch on and you're not going to be successful in this. And this is really opening the gates to our quadratic equations for the rest of this semester. You need to be comfortable with this. So go ahead and pause this now and try 6b. Alright, I hope you found success. I did tell you that I'm going to do the same thing every time. I'm going to list that SADMEP over on the side, and we'll see how you did. Okay, there are 2 numbers attached to x this time. 2 is multiplying, and this 2 up here is an exponent. We need to undo each of those, but notice none of them had addition or subtraction, so we move on to multiplication and division first. So we undo the 2 that's multiplying by dividing by 2, right? Okay? And we end up with x squared. Let's see, half of 32, I think is 16, isn't it? Yeah, that looks right. Cool. So once we're here, we've undone multiplication and division. Now we're down to the exponent step. How do we undo an exponent? Oh yeah, with a square root. Square roots undo squares. And that leaves x by itself. Notice I did have to do the square root to both sides here. Whatever you do to one, you do to the other. Oh, and I introduced a square root, which means I need a plus minus. What is the square root of 16? The square root of 16 is 4, but don't forget that there are two answers here, both positive 4 and negative 4. And that takes care of the exponent. All right, let's continue. 6c. Again, working through SADMAP here. We need to, I think, isolate x, and the only thing that's attached to x right now is a square. That's easy. We just need to undo a square by, oh, you guessed it, introducing or writing in a square root. These cancel, and it leaves us with x equals, wait, how do we do the square root of a fraction? Do I need to turn that into a decimal? Well, no, you don't. Fractions are, in my mind, generally superior to decimals because they don't use decimals. Fractions are just made up of two nice numbers, and it's easier to do math with nice numbers than with decimals. And with a square root here, it's really easy because we are allowed to distribute a square root when there is division or multiplication. So I'm going to distribute the square root to 16 and distribute the square root to 9. Once we've distributed the square root, the rest becomes really easy. We just do the square root for each number. The square root of 16 is 4. Square root of 9 is 3, and we're done. Some people ask, wait, where does the plus minus go? Does it go to the 4? Does it go to the 3? Does it go in the middle? And the answer is, it doesn't matter. You can put it anywhere, any one of those three, and it's all the same. Alrighty, at this point, we've gone through and done 3 problems, so it's time to introduce you to the meme. I actually have 3 of these memes, and I believe, and you guys can correct me if I'm wrong, that these are attributed to Bowman Dixon. He has a pretty fascinating blog, and this is where I first saw these. There is a puppy one, a kitten one, and a bunny one. The only one we're going to do this year is a puppy one, though. And it's just a nice visual to remind you of what we saw on the previous page. What this person has done is they've written a square on the outside, and they've said, ooh, we can distribute a square. X squared times itself is x to the 4th. 3 squared is 9. And so we get this. But oh no, no, this is bad. We are not allowed to distribute a square if there's addition inside of parentheses. Don't do it. Same thing. What they've done here is they distributed the square root to each of these pieces. Square root of x squared is x. Square root of 9 is 3. That is bad. If there is addition or subtraction, you cannot distribute a square or a square root. Don't try it. Don't do it, because not only will you get your problem wrong, you will also reduce the population of the world's puppies. And this guy's adorable. Look at him over there. Yeah, we want to keep him happy and alive. All right, continuing through. There are a bunch of problems here, and same thing as I mentioned before, you should pause before each one. I'm just going to continue through, though, and see what we can do. Here we go. SADMAP it is, every single time. We need to analyze this problem and see what's attached to x. I see a 3 that is multiplying. I see an exponent of 2. And I see a 75 that's subtracting. Out of these 3 numbers, 3, 2, and 75, which one do we undo first? Well, we look at our order over here, and it says undo whichever number is adding or subtracting, and that is the 75. So I'm going to rewrite this so I have a little bit more space over here. 3x squared minus 75 equals 0. And I'm going to add or undo subtracting 75 to each side. 0 out, so we end up with 3x squared. 0 and 75 is 75. Okay. From here, we have undone all the addition and subtraction. What's next? Multiplication and division. The 3 is multiplying, so we undo the 3 from each side. And that leaves us with x squared. Let's see, 75 split into 3, think quarters. I think that's 25, isn't it? Nice. We've undone the multiplication and division. Now we move over to the exponent part. Well, how do we undo the exponent that's still attached? Well, that is with a square root. So I need to introduce or write in a square root. Don't forget your plus minus. That undoes the square. You have to do it to both sides. The square root of 25 is 5 with the plus minus. And that's it. Now on the right side, it does say check both answers. I'm going to go ahead and check one of them and leave you to check the other. I'll check the negative answer. But what you should really do here is you should check positive 5 and you should check negative 5. We want to make sure that we did everything right. And so our problem was 3x squared minus 75 equals 0. We're going to replace the x with our answer. I'm going to do negative 5 here. You guys are going to do positive 5. And now we are following PEMDAS. We are simplifying the left side to see if it becomes 0. So PEMDAS, we start with what's in the parentheses. There's nothing with negative 5. Then we do the exponent. Negative 5 squared is 25. Negative 5, negative times a negative, right? Now we're on the multiplication and division. 3 times 25 is 75. And finishing off, 75 minus 75 is 0. We got the answer right. If you ever finish early on a test, you should do this process. You should go back through and check each of your answers and make sure you are correct. Let's try our next one. Again, you should pause and then do it on your own and then check your answers. I'm going to rewrite this problem quickly though. I like it to be, no, actually I'm not in this case. I'm going to do SADMAP over on the side because I know I'm actually going to need a bit of room here. And in fact, you're probably going to want to divide your paper in half. So let's go ahead and see what we can do. We start with addition and subtraction, so we're going to add 11 to each side. That leaves us with 3x squared equals 72. Okay. Next up, we undo multiplication and division, so dividing by 3, just like that last problem. X squared equals, I think this one ends up being 24. You should probably double check that. Okay. And then we undo our square. To undo our exponent, to undo our square here, we write in a square root with a plus minus. Okay. These undo, and we end up with x equals square root of 24. See, what times itself is 24? 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. Oh, we skipped over 24. That's because 24 is not a perfect square, is it? So if you wanted to double check that, whip out your handy dandy calculator and try the square root of 24. Oh yeah, we get that irrational decimal, goes forever, never repeats itself. That's not a nice number. So we're not going to write our answer as that irrational decimal. In fact, we prefer you to keep your answer as the square root, like so. However, and this is why you definitely needed to have done your lesson from lesson 6.3, that is not the answer that you would see on a multiple choice test. The answer you would see on a multiple choice test is actually plus minus 2 square roots of 6. Well, is the square root of 24 wrong? I don't think so. The square root of 24 looks good. So actually, remembering the decimal for the square root of 24 is 4.8989, right? What if I tried 2 square roots of 6? Oh, that's the exact same decimal. So I think what that's telling us then is that these two answers that I've boxed over here are the same. So then you might say, well, wait, if they're the same, how come on a test they'd show one over the other? Well, it's equivalent to if you got an answer of 5/10. They wouldn't show that on a test answer. They would show you the fraction 1/2. They would expect you to simplify your fraction. And same thing with square roots, they would expect you to simplify. So how do we simplify the square root of 24? Well, we'll give you that shortcut method from last class. So the way we do it is we take this square root of 24 and we break it down with our prime factor tree. Okay, doesn't matter what you do. Let's say that you want to do, I don't know, 4 times 6. Broke down 24. Could have done 12 and 2, 8 and 3, doesn't matter. Break down 4, 2 and 2, break down 6, 3 and 2. How does that help? Well, we learned last class that one of our quick shortcuts for reducing square roots is we can say instead of the square root of 24, we can take any pairs of numbers and those end up outside. And we can take any non-pairs, like this 3 and 2 that are right here, and leave them inside the root. And if we clean this up at all, the 2 on the outside, 3 times 2 is 6 on the inside, we can see where that 2 square roots of 6 came from. You are expected to reduce square roots. We need to keep practicing that, and there are going to be some of these on this lesson for today. How do we check this? Well, there's both positive 2 square roots of 6 and negative 2 square roots of 6. So 2 square roots of 6 and also negative 2 square roots of 6. I will again check the negative one. You should check the positive one. Let's see if I can erase this and write it a little bit more cleanly. 3x squared minus 11 equals 61. We need to substitute our x value in. This is negative 2 square roots of 6. Negative 2 is attached by multiplication though, so I think I'm allowed to distribute my square root. My square. That does not kill puppies. This is multiplication. We're good to go. So I have a 3 on the outside. This becomes negative 2 squared, and this becomes the square root of 6 squared. Simplifying, negative 2 squared, negative 2 times itself is 4. Square root of 6 squared, those cancel, that's just 6. Simplifying further, 6 times 4 is 24. I'm going to have to go off the screen a bit, but hopefully it's not terrible. 3 times 24, 3 times 4 is 12. 3 times 2 is 6, but carry the 1 is 7. And 72 minus 11 is 61. Always important to check your work. Alright, let's move on to our last page for today. This last page only has one more problem where you have to check your work, and then the last of these has you go through and just work out each problem. So definitely make sure you keep pausing, trying on your own, and then hitting play on the video to make sure you're doing it. So here we go. Problem 3. 4x squared minus 1. I promised you I'm going to keep writing out SADMAP. I am. I think it's important you keep analyzing this problem. 4 is attached to x squared by multiplication, 1 is attached to x squared by subtraction, and 2 is attached to x because it's an exponent. So I see 3 numbers we need to undo. We undo subtracting 1 by adding 1 to each side. 4 times x squared equals 1. That took care of our addition and subtraction. Next thing we need to undo is multiplication and division. Now, looking here, we have 1 divided by 4. That is certainly a fraction. It could also be written as a decimal. I suggest you avoid decimals at all costs. Fractions are just so much easier to work with. So what do we do here? Well, we keep it as the fraction 1/4, and we do the last part. We undo the exponent by square rooting both sides, plus minus, and that gives us x equals, let's see if we can distribute this square root. We can, it's division. Okay, so square root of 1 is 1, square root of 4 is 2, and there's our fraction. That's the final answer, 0.5. And actually, that's kind of a weird one, isn't it? Because we went from 0.25, that's 1/4, and we actually found it's 0.5. This was a decimal that got bigger when we took a square root, right? Isn't 1/2 bigger than 1/4? Square roots be wild. Let's check this. Again, I'm going to check the negative answer and leave you to check the maybe slightly easier positive answer. So we have 4x squared minus 1 equals 0. So 4, we're replacing x with the answer. Negative 1/2 is the one I'm doing here, I think. Minus 1 equals 0. We have to square negative 1/2, but that's easy because we just distribute our 2. There's division. Negative 1 times itself is positive 1. 2 times itself is 4. Now we just have 1/4 of 4, and 1/4 of 4 we might know is 1. And 1 minus 1 is 0. Nifty. Let's keep practicing. The more we do this, the better we're going to be at it. SADMAP again. If I could spell. Life is tough. There we go. All right, I see 3 numbers attached to m. There's an exponent, of course. There's 15 that's attached by division, and there's 3 that's attached by subtraction. What do we undo first? Oh yeah, subtraction. Add 3 to each side, end up with m squared, we end up with m squared divided by 15 equals 3 plus 3 is 6. Then we undo our division. This one's unusual, but we see it sometimes. We undo our division with multiplication. So multiplying by 15 will undo that dividing by 15. M squared equals 6 times 5 is 30, so I'm carrying a 3. 6 times 1 is 6, plus 3 more is 9. And we finish off by undoing our square by introducing a square root. And so we find that m equals plus minus the square root of 90. But wait, if there's a square root, you should be a little suspicious because you might be able to reduce this, and in fact you can reduce this. Now I showed you one way to reduce it on the previous page using a prime factor tree. I'm going to show you a different way right now, and the reason I'm showing this other way is because this is the way I do it, and I'd prefer to show you guys the fastest ways, the ways that I try and do it. I recognize there's a perfect square in 90. In particular, 90 is 9 times 10. That's still 90. And I pulled out a 9 because the square root of 9 is 3, right? Let's show that. We can distribute a square root if there's multiplication. The square root of 9 is 3. The square root of 10 is just 5 times 2. There's no perfect squares in there. So I can't break down 10 anymore, and so we end up with 3 square roots of 10. Or, and you guys can hear the bell because I'm recording this at school, you hear m equals plus minus 3 square roots of 10. All right, let's continue on. Problem 5. Now, 5 is a whole different variety. Definitely a little bit strange. Absolutely need to pay close attention to it. So we have SADMAP once more. First, we try to undo addition and subtraction, but we can't. The addition is locked inside of the parentheses. And anytime you have something in parentheses, you can't get to it until you drop the parentheses, until you undo them. So we can't do addition and subtraction yet. We move on to multiplication and division, but there is none here. We move on to an exponent, and we say, well, can we undo the exponent? And I think the answer is yeah. If you can't undo addition and subtraction or multiplication and division yet, then the exponent's the first thing that we're going to undo. So at this point, we're going to undo that square at the very beginning, which is really weird, right? We don't normally get to the exponent right at the beginning when there's other things going on. But, oh well, weird times. We square root each side. This gives us y plus 3. What's the square root of 49 here? Square root of 49, I think, is 7. Nice. Once we've done that, then we start back over with SADMAP and say, well, we brought down the parentheses. Let's start with addition and subtraction again. And there is a 3 that's attached to y, so we do need to subtract 3 from each side, and that gives us y equals 4. Which is great, except what did we forget to do here? Oh, we forgot the plus minus. Now the plus minus doesn't go at the very end. It's not plus minus 4. The plus minus, or the two answers, go with the square root. And so what that actually means is we find y plus 3 equals plus minus the square root of 7. If there is more to do in this problem, like there is here, we're going to make 2 columns to show the 2 different answers that we need to continue to use to solve for y. We already did one of them. We did y plus 3 equals 7. We also need the y plus 3 equals negative 7. There are 2 answers to a square root. To finish solving this, we subtract 3 from each side. And look at this. Negative 7 minus 3 is not negative 4. Negative 7 and get 3 more negative is actually negative 10. So there are 2 answers to this problem, and you need to list both of them. So you can either list them like I did here, or if you wanted to put them as one answer, you could say negative 10 and 4. Definitely a little different. Okay, let's go ahead and try one more, or a couple more here. Okay, 6. Parentheses x minus 2 squared minus 6 equals 34. And so we have SADMAP again. there are a whole bunch of things attached to x this time, or acting on x. There is a 2 that's subtracting, a 2 that's a square, and a 6 that's subtracting. So let's start with SADMAP. It looks like there are 2 different numbers that are subtracting to x, but I think we can only get to one of them because this minus 2 is trapped inside the parentheses. So the very first thing I'm going to do is add 6 to each side. Boop. That leaves us with x minus 2 squared equals 40. We would also want to try and undo the minus 2 here, but the square is on the outside. And so we're going to have to undo the square first, going a little out of order, jumping down to the exponent, and we undo that square. Plus minus, and we end up with x minus 2 equals plus minus the square root of 40. But looking at this, I'm not sure I know the square root of 40. I think that's not a perfect square. 6 times 6 is 36. 7 times 7 is 49. Yeah, this one's not a perfect square. And so we're just going to keep it as the square root of 40, which is actually nice. We don't need a decimal. We don't need to do anything weird. I think from here, we can just finish isolating x. How do we do that? Well, we undo the subtracting 2, and we add 2 to each side. Now this may look intimidating, and you might think, wait, do I add 2 to the 40 to make it square root of 42? No, you don't. We don't combine our square roots with a number that's outside of the square root. And so what most people actually do is they either write this as plus minus the square root of 40, and then the plus 2 at the end, or it's more commonly written as the positive 2 first, and then the plus minus square root of 40 at the end. And hopefully you've realized that you don't need to put the plus in front of the 2. It's positive right there. And that is a great answer. But wait, there's still more. And the still more here is that wouldn't be the answer on the test, because we can reduce that square root of 40. Right? So let's look at that square root of 40. I'll show you the reducing using the factor tree, though I think it's slower because I see 4, which is a perfect square there, but it's not that much slower. Breaking everything down. So instead of the square root of 40, what we're really going to say, let's see, I see a pair of 2's right here. They don't have to be right next to each other, so that goes on the outside. And then I see our 5 and 2, which don't have pairs, so they go on the inside. So I think our square root of 40 is 2 times the square root of 10. And so what happens over here is this actually is written as x equals 2 plus or minus, and instead of the square root of 40, it is 2 square roots of 10. All right, 3 problems to go. We got the rest of these. Here's problem 7. Following SADMAP, once again, not a surprise. The more times you write it, the more it cements into your head. I see a bunch of numbers here. I see a 1/2 that's multiplying. I see a 1 that's subtracting, a 2 that's squaring, and an 8 that is also subtracting. SADMAP, let's undo the subtracting 8 first. Leaves us with 1/2 times x minus 1 squared equals 8. Do we undo the 1/2 or the square first? Well, since the 1/2 is multiplying and the square is an exponent, we undo the 1/2 first. And although you could divide by 1/2, we learned last semester it's generally easier to multiply by the reciprocal, 2 over 1. 2 over 1, though, is really just 2. So those undo each other. We end up with x minus 1 squared, and 8 times 2 is 16. Now we undo the square by introducing a square root plus minus. That leaves us with x minus 1. The square root of 16 is plus minus 4, which means we actually need to solve 2 equations, and I'll use the space up above to do that. We need to solve the equation x minus 1 equals 4, and also x minus 1, that's a 1, equals the negative 4 answer. Luckily, these, especially using SADMAP, is pretty darn easy. We add 1 to each side here, and that gives us x equals 5 But don't make the mistake and think, oh, the other one's going to be -5. It does not work that way. If you add 1 to both sides here, hopefully you recognize that -4 plus 1 is -3. And so we have two answers. We'd probably group them together in these braces and say from -3 to 5. 2 problems to go. We're solving for A this time, but very, very similar. Working through SADMAP once again. Let's go ahead and undo the addition and subtraction first. I think we'll undo this 24 that's on each side. So that gives us -3 times a plus 5 squared equals -24. And then we continue through. We say, okay, well, there's some division now because -3 is multiplying. We might as well divide both sides. A plus 5 squared. -24 divided by -3 is +8, I think. Let's continue through. Now we introduce our square root. We're getting good at this, I hope. Plus minus. That leaves us with a plus 5 equals, I don't think there's a nice square root of 8. 2 times 2 is 4. 3 times 3 is 9. Yeah, 8's not a perfect square, so we'll just keep it as the square root of 8. And then we finish off. So we subtract our 5 from each side. And although you could put the -5 at the end, convention or tradition tells us that we usually put the nice number in the front and the square root at the end, not forgetting the negative that's on there. And although this is the right answer, guess what we have to do with the square root of 8? Oh yeah, we need to simplify. But the square root of 8 is a pretty easy one to break down. I see a perfect square in there, a perfect square of 4. So we can go through and take the square root of 4. The square root of 4 is 2. This guy doesn't have a nice square root, so it stays here. And thus we find our final answer of A equals -5 plus minus, and it's not the square root of 8, it is 2 square roots of 2. Last problem. Finally, woohoo! I'm not even going to write SADMAP this time because we are so good at it. Add 8 to each side. -2, x plus 7 squared equals +8. Now we undo the multiplication or division. In this case, multiplication, divide by -2. X plus 7 squared equals -4. And then we undo the square. So introduce that square root. And we end up with x plus 7 equals, wait, didn't we talk about square roots of negatives earlier? I don't think we can do those. In fact, I think we said that they were not real numbers. And in this case, that is true. The square root of -4 does not exist. And so what do we say here? Well, if you get to a point, just like when we are solving absolute value, then there is no solution here. Technically, we say no real solution because there is a way to take square roots of negatives. We don't learn it this year though, so there's imaginary solutions, but yeah, we're just going to go with no real solution. If you say no solution, no one's going to mark it as wrong, but no real solution is probably the best way to do that. So thank you so much for tuning in. I know this was a long video, but hopefully you got a lot out of this. And of course, you can always fast forward through the parts that you don't understand, though I'm telling you this at the end, so maybe that's not super important. And I'm excited to have you guys back next class for our last lesson here, which is going to bring our graphing parabolas back in with these solving equations and do a nice connection at the end of this unit.